So here is our next problem, and the first thing we must do is decide, is this phase known or phase unknown? Well, because we have two deceased people, this is going to be a phase unknown pedigree, so we have to use this equation. And because it's a phase unknown, we're actually going to have two hypotheses, and I will show you what I mean. This person can either have the disorder on marker 1, so it could look like this, or we can have the disorder on marker 3, so it's flipped. So for this problem, you could just assume it's one or the other, solve for one, and then flip the values here when you plug into the equation. So here's what I mean. Let's solve for the disease gene being on this set. So if you have a 3, that means you're shaded in because you have the disorder. So now let's solve for these kids to see if they are recombinant or non-recombinant. So this person has the disorder on 3. And then let's just quickly do the mom. She will be like this because she doesn't have the disorder. And then she got a little d from mom. And this makes sense. There's no crossover happening because you get this set from dad and this set from mom. So we're going to classify this as non-recombinant. Something similar is here. You get the normal big D from dad, 3, so you're shaded in, and then a little d, 2 from mom. Now, so this is going to be a non-recombinant. Now for here, you get a small d from dad, and then small d4 from mom, and this person is not shaded in, which is what we expect. So this is not recombinant. Here, though, we have a shaded in person, even though they have these two sets. So this means that crossover occurred, because normally D1 means that you don't have the disorder. So what happened was crossover most likely occurred to have the disease gene on the 1. So it'll look like this. So that means recombination took place. Now for this person, we have D1 as normal, and small d2, which is what it's supposed to be, so non-recombinant, no crossover occurred. And similarly here, we get the disease gene with 3, and then small d, which 2, which is expected. So this is non-recombinant. So now that we classified everything, we can count how many we have. So for N, we have 1, 2, 3, 4, 5. 5 non-recombinants. R is 1. 1 recombinant person, so our total is 6. And we can plug into this equation. One half theta to the first, 1 minus theta to the fifth, plus 1/2 theta to the fifth, 1 minus theta to the first, over 0.5, which is the total of 6. So now we can put everything into our calculator and plug it all in. So we have the log 0.5, and then again, we're going to be using these values for theta, putting them into the equation, and then seeing if we get the LOD score greater than or equal to 3. So we have 0.5, half of our theta, 0.05 to the first, 1 minus 0.05 to the fifth, plus 0.5, 0.05 to the fifth, 1 minus 0.05 to the first, all over 0.5 to the sixth. And we get 0.09. So I'm going to go through and plug everything in, and then I'm going to put it back here. So after plugging in all the values for theta, we get these numbers for the LOD score. And because we don't have a LOD score greater than or equal to 3, our answer is going to be no, the disease gene is not linked to the marker.